All right. Good morning, everyone. I think we start right on time. So welcome to the session about speed dating with Microsoft REST APIs. My name is Michael Riffley. I'm working as a solutions architect and as a partner at Scopewise, relatively small company located in Switzerland. We are focused on Azure platform and Microsoft 365, mainly for as a systems integrator. In my spare time, I blog, I do conferences when there is the chance to go physically, but nowadays, it's of course still virtual, but I'm looking forward to see some of you again at the physical conference soon, really. So the topic of today's 45-minute session are REST APIs. Why are they important? Why should you care about making yourself familiar with the REST APIs? And we will see a lot of demos and live hacks how to use them. So first things first, REST APIs are not a new thing. They are there since decades, but they are coming more and more popular because of the architecture of modern cloud applications or modern cloud native apps. Almost every, or I would say every native cloud application nowadays has some kind of a application interface in form of a REST API to interact with the user and the data behind the application. So the principles of a REST API are relatively simple. We have a web client or something else, a rich client, a fat client, a desktop application, which interacts with a so-called front-end API. This API is an application programmable interface, which is acting directly with data in the background, or it's layered with other APIs behind the scenes. So we maybe have a front-end API, which takes care of getting the user requests from the web client. Then the front-end API forwards the calls to a middleware API and so on. So it's stackable. Another thing which is typical for REST APIs is the stateless behavior. So a REST API shouldn't have a state. You should be able to make a certain call to an API endpoint several times, and you should get the correct result back all the time. So it should not have a state which has to be saved on the client or on the server side. But anyhow, the state is kept on the client side about the status of a call to a REST API, but the server doesn't have to store anything about calls made by applications or users. It's portable, so a REST API should not stick into a certain, let's say, architecture for a front-end client. So a REST API should be there to allow different types of clients to interact in a similar way with the application. So it shouldn't matter if you're using a mobile app or a desktop app. The methods by the API, supported by the API, should be the same for any type of client application. REST APIs have methods. They are so-called resource methods, like you are going to get a resource or you're going to create something. Let's say you're going to create a new order in your order table with a put request, and then you're going to get some products of your product database by issuing a get request to the products resource endpoint and so on. These are typical methods you use in the REST API world: get, put, post, patch, delete, which means get is read, put is generally something you're going to create, post also, put or post are similar. They are mainly used to create something, where patch is used to update something which is already there. And of course, if you're going to delete an object, then you issue the delete command. So If you're going to access an API, then you need, of course, to know the URL to the API. So in this example, we have the URL of the Graph API, graph.microsoft.com with the version 1.0 and with an endpoint named users. So if we would issue this command, the get command to this URL, this endpoint, then we would get back all the users from our Azure Active Directory. If we want to change a user, then we need to put or patch to change the method to put or patch, and then we going to create or also change an existing resource, which is different to the get method. Get methods don't require anything more than just pointing to the right resource endpoint. Let's say if I want to get the information about my user, then I would just add slash here and then my object ID or my user principal name. I don't need nothing more to provide to the API. But as soon as I want to create or update things in the backend, I need to provide a body, so-called um, uh, JavaScript object notation formatted body, a JSON body in this form, for example. So I'm gonna initiate a put request to this API. Tim Smith at contoso.com is going to be updated. He will get a new display name. So I need to provide the display name in the form of a JSON object. That's the main difference between get and all the other methods. So why should I even care about using the APIs natively? There are PowerShell modules, there are SDKs, so why should I even bother myself with learning how to interact with APIs? There are different, a lot of different scenarios, even more than you see here on the slide. But a typical one is you have third-party systems you want to integrate with your Azure AD, with your Microsoft 365 environment, or whatever service you have in the cloud. So you want to integrate systems like a ServiceNow or any other type of third-party system should be able to, let's say, pull users out of Azure AD, interact with user and objects with different applications. So a lot of systems have existing interfaces in form of a webhook request they can initiate, or a REST API call, or a web request. So using REST APIs is very flexible when you need to integrate third-party systems with your Microsoft 365 environment, because most of them have a way to issue or to call a web endpoint. While a lot of applications do not have a native integration for PowerShell, for example, if you're familiar with PowerShell and you're using all the fancy modules which are around to interact with Graph, for example, that's fine. That's perfectly fine for your desktop client for your administrative tasks. But uh, most of the applications do not support natively calling PowerShell scripts and when you have to integrate them together. Data export reporting is a big thing. If you want to report or just get information out of the Graph API, then of course you also have modules, but then you need to find the right module. All the different modules have certain ways how to authenticate against Azure AD and Graph API. It becomes a little bit cumbersome to combine all the required modules into a single solution after that. If you want to create your own app, your own front end, maybe you want to create your own front end, how a user could order a theme or a Microsoft 365 group, then that's pretty how you're going to make that happen with a little static single page application in the front end, and then calling the REST APIs of the Microsoft Graph, for example. Another thing about the modules, I think you are familiar with that one. You have the Azure AD PowerShell module, which is targeting the legacy Azure AD API. Then we have the even more legacy module, which is still in use, the MS Online module, which is also targeting the legacy Azure AD API. And then we have the Graph API, which is used by the Azure AD Preview module. So this PowerShell module is in preview since I like since forever, and it doesn't seem to get out of preview soon. So um, to let's make it easy for now to be able to automate all the different ways to interact with Azure AD. You need at least MS Online and Azure AD Preview. So you need both of them to do them the automation. And both of them have different ways how you authenticate against Azure AD. MS Online is very legacy, where Azure AD has more ways to authenticate against Azure AD, but it's hard. I have to admit, even I love PowerShell, it's hard sometimes to find the right module to do something to achieve the goal. Popular REST APIs, we're going to I'm going to show you mainly the Graph API, but there are others. So the Azure Resource Management API is also powerful. The Azure Resources APIs, there are tons of them because every resource has its own API and its own namespace. So if you want to interact with let's say a key vault, or you want to create your own front end to store and retrieve keys from a key vault, and that's perfectly fine using the REST API for key vault. Azure is also we are often using Azure DevOps API to automate Azure DevOps configurations. And if you want to have let's say a big overview how which kind of APIs are all out in the wild there provided by Microsoft, here's the link. So there's a REST API browser, which directs you to the available REST APIs, and of course also the documentation and examples how to use them. Every REST API needs an authentication, so you cannot just call a web endpoint like the user endpoint for Graph API for Azure AD and just initiate the delete user object. That doesn't work because you have to first authenticate yourself and you have to provide um, the information that you're authorized to do the operation. So we need permission and we need an authenticated session to do that. Microsoft is mainly using the identity platform, respectively Azure AD with the OAuth Flow 2.0 to get so-called access tokens, which are then equipped with the right permissions, hopefully, to do the stuff you want to automate. You typically authenticate with either a user, so interactively. That's what we know if we connect Azure AD, if we initiate the command, if we go to the Azure portal, whatever, we are going to interactively authenticating as a user. Then we have the method of using a service principal or an application, direct or delegated. I will talk about that in a minute, what the difference is there. And the third way is to use a managed service identity, which is a kind of, let's say, a service account, which could be compared to the group managed service account object in Active Directory. So it's an account where you don't have to care about credentials. You don't know them, so it's managed by the system, and it's also the secret is rotated automatically and periodically behind the scenes. It's you cannot use it to log in interactively. It's mainly there to have an automated scenario between component A and the component B. Maybe component A is an Azure function and component B is the Azure Microsoft Graph API. And you want to interact with the Graph API, then you can use the managed service identity of the Azure function and grant permission to this identity. So you don't have to deal with secrets and certificates to authenticate. That's an interesting thing. Although it's not supported by all services now. An important thing is that however you're going to authenticate, it doesn't matter how you do it, you need an access token to be provided to the API. So the API wants to have an access token when you interact with it, and the identity platform is then used to generate an access token, and the access token is then returned to the API. An important thing here is that the access token contains all permissions at the moment you're going to um, get the token. The token includes all permissions of the principal or the user which has made the token request. So meaning that if you are in possession of an access token, you don't need nothing more to interact with the API. So the token is a critical thing. If someone steals your token, then at least for the duration of an hour, he has the full power you had when you requested the token. So that's a thing you shouldn't give away just easily. To explain a little bit how this works in detail. So it's a little bit simplified here. It's behind the scenes, a lot of things happen, but to make it easy, we go by the assumption that the user has a web app or is using PowerShell to interact with the Graph API. He first needs to sign into Azure AD, okay? So he has provided username, password, single factor, multi-factor, whatever. He is authenticated. Azure AD returns a successful authentication. Then the application is going to request a token, so-called access token. In this access token, we need to provide a scope. In this example, we just using the default scope for the Graph API. So Identity Platform knows that we are going to talk to the Graph API, and we need to give a scope in terms of what permissions we are going to request. So if you're just using the default scope, we will get all the permissions this application already has been granted in Azure AD. So the access token returned here contains all the permission this client has to interact with the Graph API. Then this JSON Web Token has to be returned when we talk to the API. So if we make a web request to the API, we have to provide the token as an authorization method. And if that all is correct, the token has been successfully verified, then we get the data back. So the token we get here is usually valid for 1 hour. So as long as we have an automation mechanism that doesn't take more than an hour, we are fine with getting a token and then working with the token for an hour. These token lifetimes can be modified, but by default, it's valid for an hour. Authorization is a big thing. How can we make sure that in the example I'm going to show you in a few minutes, how can we make sure that my application has only the permissions it needs and it doesn't have the power to delete all the user accounts from Azure AD, for example. The important difference here is that we have so-called application permissions, application native permissions, or delegated permissions, meaning that if an application has application only permissions, I don't need a user to interact with the Graph API. The application has been granted with some permissions on the Graph API, and as long as I have the application ID and the secret or the certificate to log in with this user principal, I can do pretty anything which has been granted to this application in the background. So I don't need an interactive user to log in. It can be used to automate things in the background, which is a common scenario, of course. Delegated permissions, they are kind of different. So it's not the app which has, let's say, the resultant set of permissions. It's the user in combination with the app. So to get an access token for the application, we need to first initiate a user interactive signing. So a user with its username, password, MFA, whatever, has to log in before the application can request an access token. So this login, also this is very simplified here, will return an authorization code. The application is then using this authorization code to get the access token, which means that an application can never have more permissions than this user. So even this application could potentially delete all the users in Azure AD. If this user does not have the permission to do so, it will not happen. So that's the more secure way, because we have a combination of user permission with the application. In this scenario here, it's sufficient that we grant some permissions to the application, and every user which is in possession of the secrets to log in with this service principal has the full power. That's speaking about examples where to use what. This is mainly used for background automation scenarios, and this is mainly used for web applications which are which have a front end used by individuals like real users. Well, of course, here, if you have a process or a script or a runbook or whatever you have in the background, you cannot initiate an interactive user login. So you need to automate that, and that's the only way to do it. We will see that afterwards. Not every REST API endpoint does support the same level of permissions. So not all operations of Graph API, for example, support application-only permissions. So that's a thing you need to consider if you want to automate something. You're going to check first what your scenario is, this or this, and if the API even supports this type of permission granting. If not, then you need to wait until it's supported, or do it in another way. The app consent is also an important thing. So I think most of you are familiar with the little pop-up when you're going to use a new SaaS application. The user is being asked for giving consent to the application. So the application might want to request reading data from the user profile, from the user mailbox, from contacts, and so ever, whatever. The application asks the user to consent this request. And if you don't disable this on your Azure AD tenant, by default it's enabled, so every user has the power to consent or to give consent to new applications and give them access to his own personal data. Where the admin consent is something you do as an admin for all users. So you're going to give consent to an application, so the app will have the permission to access all users' mailboxes, for example. That's the main difference. A short thing about return codes. Everything above 200 something is a good sign. 400 return code something is not so good. It's mainly because you are not giving the correct endpoint when you're calling the API, or you have a malformed body when you're going to initiate a put request. And the 500 error is an internal error. So you're going, if you get a 500 error back from your API call, then it means, yeah, you're doing really something completely wrong because the service not even handle the exception. So the 500 is mainly an unhandled exception inside the API. But as long as you get the 200 something back, then you're pretty good to go. So how are you going to start even with interacting with the Graph API? So in this simple example, I'm going to register an application in Azure AD. Going to create a secret. In this demonstration, I'm going to use a certificate to authenticate with the application. We are going to assign API permissions to the application, where we need also then to grant the application using an admin grant consent. And then we are going to generate an access token. From there on, I'm going to show you the examples. So first thing first, we could do that with Azure AD. So We could go in here in Azure AD to app registrations and then create a new application. So demo app something. We don't need to provide a redirect URL here just to interact with the API. We could do a register. And we are going to create a certificate or a secret. In this example, I'm going to create a client secret. So that's maybe valid for 12 months, test, whatever. So the thing I need to authenticate with a service principal or a registered application is now this secret. I need to have the secret here, and I need to have this information here, the application ID, the directory or tenant ID, and the secret. That's sufficient to authenticate, but of course it's not very secure because everyone who has access, read access to Azure AD can read this information here. And if someone writes the secret somewhere he shouldn't, everyone will have access to this application and can use it to interact with the APIs we're going to give permissions to. So the API permissions in this case here are user read is just a default delegated permission every application gets when you create it, but we might need to add permission here. So let's say I want to interact with Microsoft Graph. There are other APIs, as I told you 5 minutes ago. Microsoft Graph, I want to automate something using maybe a runbook or something. So I need application level permission, not the delegated ones. Application permission, and I'm going to search for, I want to modify groups. Group. So I want to create groups or read groups or even create, read, delete, and modify groups, then I need to give this app this permission here. So group, read, write, all is a permission scope for Graph API. I'm going to assign this to the application. And now I can see that this application permission on the Graph API has not been granted on the tenant. So an administrative user with usually a global administrator or a security administrator is going to grant this admin consent to the whole tenant. So I need to do this, otherwise the application will not have the permissions. If this is going to get green, everything is fine. And we could start to work with the Graph API. The scripts I'm going to show you are available on GitHub on my GitHub page under Azure PowerShell scripts. I'm just going to do this again. So I have a little script here, which is going to create a new application named, in this example, the SPI graph demo. It's going to create it in our lab tenant. It's going to have user read all, group read all permission. So these are the permissions I'm going to assign to the new application, and let's do that now. I'm going to create a new application with, if I would be in the right directory, sorry for that. I'm going to create a new application with a certificate, which is more secure than just having a secret, because every application or system or user which want to interact with this application needs to have or needs to be in the possession of the certificate. So it's more secure than just spreading a secret all over the world. So with this command here, I'm going to create an access token using the certificate, using the new application, and I will get an access token in form of a JSON web token here. So if this access token I could copy away, it would be valid for 1 hour without without the need to refresh it. So I could copy away this text and hand it over to another user, and he could then go with the authentication header here. So we need to provide an authorization before calling the Graph API. We need to give the access token in form of a bearer token definition. So that's just the authentication header here. Then I need the graph or the REST API endpoint. In this case, I'm going to call the user's endpoint. So the URI will be this one. And I'm going to invoke a REST method using PowerShell in this example. This could be any programming language, of course, but for the sake of this demonstration, it's easier to just show it with PowerShell. Invoke REST method. The method will be get. The URI or the web endpoint is this one here. And I need to provide the authentication header. This will return a value, which is then saved in the user's variable. So let's go with that. And I should have all the users as a PowerShell object getting back by interacting with the Graph API. Of course, I also can get a single user. So in this case, the user's REST endpoint would not be sufficient because I want to get the specific object. I could use the object ID or the user's principal name, and I will get the user information here. Okay. So I'm not really happy with, let's say I'm not really happy with my job description. I'm going to search for myself here. I'm not really happy with the job description, neither with the image. So some funny guy uploaded this image to my profile. I want to change this. This is, of course, also easy possible using the Graph API. So I'm going to update my user. So this is the new job title saved in this variable. I need to create this JSON body as we have seen it in the slide deck. So I want to modify the job title. So I need to create a JSON valid body object. Also, I need to the URI, of course, again. So this object will be modified, and I'm going to invoke the REST method with the patch variant. So I'm going to update the object using this input body here. Okay, so let's do that. And now I get an error forbidden. So REST API returns 403 forbidden, which means that this application does not have the required permission to do the operation. So let's search for this demo app I have here. This is this one I just created, yes. So let's go to the API permissions, and we're going to add a permission to write to user objects. User read write all is that we are going to need. Give the administrative consent. So this should work. If not, I'm going to clear the token cache. I'm just going to request a new access token. Why do I need to request a token again now? Because in the moment I'm going to request a token, the permissions granted to the applications are then included in the token, which is returned. So my recent access token does not include the user write all permissions, so I need to get a new one. And also the authorization header will be refreshed, and we're going to retry that. It will return forbidden because the token is cached on my client, so I need to clear the Token cache. And again, refresh by using a new access token and then try to do that again. So that seems to work. Let's verify that. Job title has been updated, but the image is still not correct. So let's update the image. I'm going to get the image here. I don't want the Fox image. I want something else. Let's say, let's use this one here. It's not much better than the Fox, but just for demonstration, we're going to use that one. I need to encode the image into a binary value, and then I can use the same Graph API endpoint to update my user/photo with the value of the image. And let's write that. Update photo. So refresh here. Okay, much better than the Fox. So that's an easy demonstration how you can interact with PowerShell and Graph API. A lot of the other APIs work in a similar way, so you need to provide or you need to get an access token first using a application only or a delegated authentication mechanism, and then you can interact with the access token against the APIs. Remember to assign permission to the application first. So without an application with the correct permission, it will not work. So what other ways do we have to interact with the APIs? Let's say for we don't know the endpoint, we don't know how to interact with certain endpoint, so we need to get the information somewhere. Microsoft Graph Explorer is a good tool, and Postman is a good tool. I'm going to show you both. Microsoft Graph Explorer is where you're going to explore Microsoft Graph, obviously. So it has a rich web interface. You can sign in with your user, and speaking about that, you notify that, or you note that this way how we're going to interact with Graph API is not the application only permission, it's the delegated permission, because we sign in as a personal user, and Graph Explorer will not have more permissions than I have with my personal user signing into Graph Explorer. So I'm currently signed in, and here are some sample calls. Let's say I want to read all groups, get all groups in my organization. I just click here, and it will create the right endpoint, and I can run the query. And if I am in the possession of the permission to read all groups, this will return the objects here. Okay, so this is an easy way to get started, to interact with Graph Explorer, to try out some things, to test some functionality before you go into your automation script or application or whatever. You can, if you want to do something which is not granted to your user right now, of course, you need to have global administrator or user administrator, depending on what you're going to do. If you don't have the permission and you run the query, you will see the permission which have to be consented here to execute the query to get the results back. And all the things you go into consent here, then you can easily revoke later on again. So if you go to Azure AD Enterprise application, in this case, we're going to search for Graph Explorer. So this is the enterprise app, which is behind this web UI. And this application already has a lot of permissions with the delegated model, which have been granted, because we are also using it a lot to test and to verify things. But I can easily revoke all the granted permissions from any user who has ever used Graph Explorer. And again, you don't need to be scared about users going to delete all groups, because they need to have the permission as a user. If they are not in an Azure AD role, respectively having this permission, they cannot using the power of Graph to delete all the group objects, for example. So that cannot happen. If we need to get deeper into the API documentations, then we have the documentations here. So I'm going to the API reference. I want to interact with, let's say, teams. I'm going to team. I'm going to see how I'm going to have to create a team. So here, this information contains the required permissions I need. So I want to automate it. So I need to make sure this type of endpoint supports application permission. If here is stated that it's not supported, then you can only work with delegated permissions. But in this case, it would be supported. The endpoint is Teams. So graph Microsoft.com/Teams. And I need to provide a request body. So the only thing I need to provide is the team template, display name, and the description. That should be sufficient to create a team. Let's see how this works with using Postman. That's the last tool I'm going to show you, which is also a good thing for developing, for creating a solution, because you can save your queries and you don't need to store them in text files or whatever. So let's open Teams first. So I want to create a team using the Graph API. I'm going to do this with Postman. Postman is a tool to interact with REST APIs, to save, to create group of queries, to save them. It's just like a snippet saving tool. And of course, you also can create environments here. I have created an environment which contains the client ID, client secret in this case, and the tenant ID, which can then be used as variables. So I don't need to provide all the time these variables to the requests. So I can get an application access token using this environment variables. Let's do that. Let's get the access token. This is the bearer token here. And I'm going to create a team, which is, as we have seen, Graph Microsoft.com. In this case, I'm going to use the beta version and the endpoint of Teams. So this is going to be called with the post request method, and this is the body for the post request. So CloudEight demo team, blah, 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 going to create it by Postman, and I will be made as an owner here. So let's execute that. I'm getting back hopefully a 202, which means it has been accepted. It is an asynchronous task which is running behind the scenes now, and I'm already becoming a member of the new team, CloudEight Demo. So that's how easy you can create a team using Graph API, and some flavor of automation of your choice, of course. So a thing about security, use certificates wherever possible instead of secrets. Grant consent with the least possible privilege. So don't create an application and assign all the possible Graph API permissions you could potentially consent to the app. So least privilege is an important thing here. Don't create the one master application which can delete the whole directory wherever possible. Don't store secrets in code, of course, which is nothing new. To store and pull the secrets from Key Vault if you need them in an Azure function or in an Azure web app. Don't store it in the code. Get it from the Key Vault, which is pretty easy to make. Some other tips. We talked about, or I talked about token lifetimes. So when you have requests like an automation mechanism which takes more than an hour, you might refresh the token, which is also possible to with the current access token. You also get a refresh token, which can then be used to get new access tokens. If you have a lot of objects being returned from the Graph API, maybe you have 10,000 users or 5,000 users, and you're going to the users endpoint, get all users. Graph will only return 1,000 objects. And then you need to page. So you need to browse through all the follow-up links, which is then returned by the Graph API. So if you have more than 1,000 objects being returned, Graph doesn't return the 1,000 objects. It returns 1,000 objects, and additionally it returns the link to the next 1,000 objects. And you need to just make a so-called a loop to run through all the next links until there is no next link, and to get all the objects. So just if you run in this scenario, go to Google and see how you can page the results if you have more than 1,000 objects which should be returned. Throttling. Every API has throttling limits, so Microsoft protects themselves by having throttling limits. You cannot call your graph, the Graph API with 1,000,000 calls in a minute. So this will then be throttled, and you will get an error back that too many requests have been made, and you need to wait for a certain amount of time. So, sorry for that. Meaning that if you have to make a lot of requests, think about combining the requests instead of just having a loop where we're going to initiate 1,000 requests within a second, which will definitely lead into a 4.0 something error, too many requests. Short recap, powerful REST APIs can be used to automate a lot of use cases without the need to grab the right PowerShell module of the PowerShell gallery, without the need to combine them in terms of authentication, which can be a nightmare. And this can be very powerful. So if you get familiar with interacting with REST APIs, you can overcome some limits of Azure CLI, Azure PowerShell, and all the other tools which are around. And don't forget about the security. Just because it's easy doesn't mean that it's secure by default. You need to take care about secrets. You need to take care that access tokens are not given away for free to someone, because they contain all the required information to interact with certain permissions. So as a last word, thanks to the sponsors making this event possible. Thanks to Draco for inviting me for another session. Thanks for having me. And of course, thank all of you who made it so early to this session and stayed until the end. So thank you for this, and I wish you a nice rest of the conference and a nice day. Thanks. Oh, I'm sorry. If you just almost forgot that. If you have questions, feel free to ask them now. If you want to think about the things I talked about and you want to send me the questions by email, that's perfectly fine. So just write me an email, contact me on Twitter, or give me a call. So with that, I'm going to leave you to the next session or to a short break, if there are no questions. Otherwise, you can unmute yourself now. So again, if you have further questions after the event, just feel free to contact me.